Hello everyone and welcome back to the channel. In today's episode M2A 516 I will be talking about LPE, Light Path Expressions. I'm pretty sure by now you must have heard about LPEs. It's a new way to define custom AOVs, which stands for arbitrary output variables. So before we jump into this, I first want to make sure that you guys are caught up on the topic, and you can easily go to the M2A solid angle page where they have actually a nice introduction what LPEs are and what the power is about them. Obviously, it's for some of you guys, it's I guess shocking to see all these cryptic expressions to get a certain output of them. But as soon as you kind of understand the power of them, you have so much more flexibility in creating custom outputs for compositing. Obviously for single frame renders it's not that important, but for larger scene scales this is a must-have thing. And in this short demo about this little fishbowl, which the scene I got from the M2A learning site, or learning scenes actually. But anyways, I will have this scene on my Patreon page, so if you want to follow along, make sure to download the scene files and you can actually test along, write in your own LPEs and get going. Right, so we have this fish and currently we don't have any AOVs on the output list. So I'm stopping the render now and I just want to create the default AOVs, which you get, like here's a long list in them and this is the default you get. So we have scattering, we have glass, we have water, we have coat, we have lots of different shader types or shader modes. So let's just try how it works. So the most default AOVs you would pick is diffuse direct and indirect, spec direct and indirect, and scattering direct indirect, transmission direct indirect. And I'm missing the code. Where's the code? There we go. So these guys would be your default AOVs, and currently you cannot customize them because they are built into the system, right? If I click on one, select AOV node, you can see custom AOV. I cannot change the LPE, the light path expression. But let me just render that and show you what I mean by how this is a limitation. Right, so this is now the render, and now I have the AOVs in here, and you can see if I go to code, we only see the stuff which is not behind the glass. So only the fin of the fish is sticking out or visible in the AOV. And the same goes for, unfortunately, for all the rest as well. So the diffuse direct, only the floor. The specular direct, only the fishbowl. So how is that helpful? It's not really helpful if you want to change the color, let's say, of the fish, right? You cannot access that. It is in transmission indirect, but there is no everything in there. So how would you do that? How would you give Comp the flexibility to still change the color of the fish without painting or having to paint roto masks or changing the coral here at the bottom left? So there's no real way of doing this without customizing the light path expression. So, but before we write our own expression, I just want to show you what the benefit of having this is. So I will just quickly load in the finished tutorial LPEs and render that, and then I'll just show you how they look like. So as the renderer is finishing up, you can already see that there's visually no difference in the images. But the difference is the AOVs we have. So I'm not sure the saving doesn't work really well. So if I store this image now, we have 3 images in the bottom. And these images are actually accessible, or they will be provided in the scene files as well if you want to check that out. So this is the custom AOV, or actually LPE, doesn't matter now, but this is the default AOV. Default render, default AOV, and custom LPE. Alright, so now let me show you the benefit of customizing your LPEs. So if I would go now into the code, you would see that we see everything, even through the refraction, right? In the previous one, I think I can't do that. Let me see if I can, if they are here. So this is the code direct from the previous render. You see only the fin sticking out. And if I go to the new render and I go to the code direct, you see the whole fish in there, which is very beneficial because you see the code through all the objects. So actually what it does, it totally ignores transmission, which is a refraction, and just adds those paths together. So if you check the diffuse, this is that. So the eyes are diffuse, the stones are diffuse, but they are actually looking through the glass. And let's go to scatter. So scatter is all my scatter objects in the scene. It totally ignores the refraction of things. So this is a very convenient way to just gather whatever is scattered. If it's refracted or not, it doesn't matter. It goes all in one output. And if I switch back to the previous one, where we have the SSS direct, we only get the fin, right? And in the transmission indirect, we get the whole scene in here, which is very unhelpful, and you cannot really work with that. So if we check again the other passes, I've got my specular, which is the whole thing, specular. Then I have my specular indirects, and it all ignores transmission. This is my diffuse albedo or scatter albedo indirects. And I hope you understand like how beneficial this is. It's very helpful. Again, so let me first, before we write our own AUV, I just first want to talk about these expressions, like how are they being set up. So you need to understand that an LPE always starts with C, and C stands for camera. So it is a ray type. So you are searching, like these expressions are search paths for a certain ray type. So I hope it makes a kind of sense. So you can see that everyone starts with camera. So the ray is being fired from the camera, and then the first thing it hits is one ray type, and then it checks and searches for another ray type and another ray type, and in the end it gives it the result which it's looking for. So let's just start with the top ones. So camera.star means it from the camera ray, it takes any event and then any other event. So this means I'll just do anything I find as a ray type and I'll output that. So this is in most cases your beauty output, which is a combination of all the ray types together. So, and then we have, let's just start with the more simpler ones. Right, so the next one is a direct. So it means camera, and then it's in brackets, and this means any type. So is it diffuse, is it spec, is it a volume? So it's A or B or C, and then light. L is for light, so all lights from these scattered types. And if you scroll down in the list, you can actually see the scattering events. So DEAM is just diffuse reflection, transmission, or scattering. And then in these brackets, bigger and smaller brackets, this is a diffuse reflection, this is transmission, diffuse, or scattering. Right? I hope this kind of makes sense. And then you have the operators. So if two letters follow each other, it is A followed by B. So A, ray type A, and then ray type A converges to ray type B. So this is kind of an AND operation. In square bracket, it means A, B, or C. And this is kind of the same A, B as one thing, as like A followed by B, or C followed by D. And this, I'm not sure how you call that, but this bracket thingy there means except. So it's kind of everything except that ray type. And dot means any event, and this is a custom event. So I hope this kind of makes sense. You need to trial and error a bit to get better understanding of this, but it's more or less, if you try a few AUVs and you create your own ones, it's pretty straightforward. So this means the camera ray hits, then it's reflection, diffuse, so diffuse reflection, and then all lights. The indirect means, so this is one scatter event, and this is another scatter event. So it's the same as the first. Diffuse direct light is this one, And then the next ray type will be diffuse, specular, volume, emissive, or background, I think is B. So any other ray type like this and then followed by this is an indirect ray. A means albedo, which is the raw color. And in the AI standard surface shader, they have the code parameter, and in the shader itself, they have tagged the shader ray type with a code. So the default specular direct is every specular reflective ray type except when it's tagged with code. So code is being ignored in this one. And then we have code, and in the code you can see it's only the code without the exception symbol right there. So reflective spec, and then code tag, and then all lights. TD is for scattering. Volume is camera, volume, all lights. So this is kind of how it works. And as I said before, you need to trial and test a few things out. So let's just create a custom AUV and see how we can do that. And for that to work, I will just reduce my AA sample just to get faster feedback, maybe on 1. And let's see if I hit play. Yeah, this should be fast enough, right? And now let's check if we go to the render globals. And let's create just a underscore, or let's say training. Training is too long. Just say ls, whatever, put light shader. And then we say custom for now. So this is the custom AUV, and now you can see we have the option to type in our own light path expression. And if you click those 3 horizontal lines, you can actually get a preset list of predefined AUVs, which is very helpful for sure. You don't need to look it up all the time. So let's say we want to create the beauty path, right? So let's just click on this guy and let's see if it actually shows up. If I update, let's see if it shows up in the list. It does. So ls custom. So this is exactly the same as my beauty pass. So now let's change a few things. So let's just try to catch all the diffuse light paths, right? I'm not sure if we will actually catch a diffuse. So let's just try to get scattering events. So camera, and then we have the smaller, bigger sign. And then we have a transmissive diffuse, which is light is passing through a surface and then outputting diffuse, which is then scattering, and L means all lights. So now, let's see, because this is glass, we don't see anything, but then again, we see the tail sticking out because this is a direct hit. And to get the transmission working, you need to understand that the camera ray hits the glass surface first and then hits a scattering. And to do so, we would first need to create the transmissive scattering event. So we do smaller, bigger bracket, and then we say transmissive spec for refraction, and then we type in any other event, and let's see if this works. And it does. So now we actually, the first ray hit is TS for transmissive spec, which is the refraction, and then followed by any other event. Let's see what it stands for exactly. The dot, the asterisk means 0 or more events after. So TS and then 0 or more events, which is TD, which is the transmissive diffuse for scattering, and then we hit all lights. And this is how I created my custom scatter type. And this is how it goes for all the other passes as well. So let's say we want to create diffuse. Instead of TD, which is transmissive, we want reflective. So it's RD. And let's see if it updates. And now we get all the diffuse ray hits through the glass and without the glass, right? And this is the power of that. So another big benefit of creating custom LPEs, you can actually isolate lights separate from the beauty render, and you can output for each light group their own AOVs. So let's set that up first. Right, so to get this to work, all you gotta do is add a attribute to a light. Let's say we want to isolate the dome, the rim, and the key. So how we doing this is we go into the light shape, and in the AOV light group you would define a name. So let's just call this something which makes sense. Let's just call it LPE, or per light. Let's call it LPE and then key, and then we have area rim. We add this LPE underscore rim, and for the sky dome we add LPE underscore ENV. So now we added 3 groups to our scene, and let's head over to our custom LPE. So currently we are catching transmissive spec and reflective diffuse light paths. So we want to isolate a certain light now. So how we do that is we, after the RD and then the closed bigger than bracket, we just create another bracket, smaller and bigger, add all lights, followed by our light group, and this would be LPE underscore rim, and hit enter. So now you can see that our LPE is only outputting the diffuse for the rim light, and you can see it works as expected, only the right light. So I'll just stop the render, and let's just rename this LPE to underscore, let's just call it maybe LPE underscore rim diffuse, right? And let's see if we can duplicate this guy. No, we can't. So add custom, call this LPE underscore key, and then diffuse as well. And we add another one, LPE underscore diffuse and ENV. So these are my outputs, which you would see in Nuke or in your compositing software. So select AOV node. I'll just copy my regex expression, head over to key, paste this guy here, and just swap out rim with key, hit enter, and go to the ENV and do exactly the same thing, just swap out the rim for ENV, like so. And now let's see if it works. So render update full scene, and it takes a while, and it renders. So this is it's supposed to be the ENV diffuse, which kind of looks like it is that. Let's just check the other ones. Oh, I just renamed it different. So this is the key coming from the left, and this is the diffuse coming from the right, which is the rim light. So all these 3 together should output diffuse, the diffuse component. So this is now how you set up the LPEs per light. So light path expression diffuse key. Let me just rename this for consistency. This is ENV diffuse. Maybe LGT would make even more sense. With LGT maybe. Yeah, so this is whatever how you want to set up your pipeline, but it needs to be clear what this thing is. Right, so now we have LGT environment diffuse, key diffuse, rim diffuse, right? So this would be the first step, and obviously if you have lots of lights, you would need to add them to this group again and again and again. So the cool trick about this is you can just create a set and just call this LGT. Let's say we want to have rim, LGT rim group, maybe GRP. So in here, what you can do now is let's just select the rim light and drop it in here. So this is now a part of this selection set. And in here, you can add an attribute, and let's see if you can find it. I'm not sure if we will be able to search. Nope. I'm actually not sure how it's called in here. I guess AIAOV. How is it called on the shape? I just checked the script editor because I couldn't find it. So if I just change the string here and on the shape, let's just add a character and hit enter, you can actually see which attribute is being changed. So that's the one we need to be looking for. So it's actually the first one. So I'm just adding that and closing the box. And let's see if it's now on this group. So now is the AI AOVs right here. So now if I remove it from the light itself and add it onto here, we should now be actually able to do so. So let's just try and duplicate the rim light just for the kicks of it and make it a top-down light. So I've got now two lights. Look through selected. So I'm looking now through my duplicated light and I'm positioning it just on top. And if everything went right, it should show up in my LGT rim LP rim diffuse. So let's see. The key is from the left. The ENV is global lights, and the rim currently does not seem to be any different. Why is there another light now? Let's just see what we did here. Alright, I found the stupid user error. So the problem was when I was duplicating the light source, it actually removed the connection to my texture and hence my color was black. So it actually all worked out. So I just have the rim and both lights, and I'm setting the LPE name in the selection set or selection group. And then you can see that my LGT rim diffuse AOV outputs now both. So if you have more lights, you just create a selection set and you add them all in there, and then you should be fine to go. So let's just recap what we did here. So instead of having the default AOVs, which limit you to, especially if you have reflective objects, all your ray types are being collected in the transmission and the refraction of this AOV. And the specular direct is only the outside and you cannot get the objects inside it. With custom LPEs as AOVs, you actually have the opportunity to define which ray types are being collected. And in this case, if I go to scatter, to my scatter, which is my subsurface scattering pass, you can see that I'm ignoring transmission and I'm collecting everything except the transmission. So if you add all these passes together, you will get the beauty result as well. So let's just check all my paths which I have in here, and let's just select my code. Is that the code? Why is this not updating? Oh yeah, you can see that my light path expression is TS for transmissive spec, and then all other events, 0 or more events, and then reflective spec, and then it's including the code tag inside the shader. And I still have L, and then I have O, which means all lights and all emissive objects as well. So if the code is reflecting an emissive object, it's being collected in this AOV as well. So let's head over to the scatter one, and you can see TS, TD, and all lights. And let's just, for the fun of it, if I go into the scatter as well, like this, let's just isolate the key light, right? So to do that, I have the brackets, the symbols, and then I'll just add my tag, which is LPE underscore key, hit enter, and hopefully I didn't do it wrong. And we only get the scatter events for my key light. And this sums it up, how to write up your custom AOVs using light path expressions. Obviously this is a bit more advanced, but I'm pretty sure if you give this a go and try to understand what all this means, you should be able to do very nice composites and output nice renders. And you can actually see how this is working here. the default is, because all lights are tagged with a default value, you should get all lights. And then obviously you have custom events. If you write shaders, you can tag your shaders with some custom events, like the AI standard surface has the code custom event. You can see it right here, how it's outputting that. So I hope you learned something. Please give me a thumbs up if you enjoyed this video, and also subscribe to my channel. And for more motivation, I'm always happy for new patrons on my patronage page, so feel free to join me there, get access to the source files and other benefits on that page. So thanks again for tuning in, and I hope to see you in the next tutorial.